All right, couple of comments or just quick notes. So, the lab practicals are graded. Obviously I don't have them here with me right now. I haven't put the grades in yet, so I'll be working on that today. And then for those, what I'm going to do is I'm going to ask for them back. So I'll probably just have you guys look at them in lab, and then if you want to continue to look at them, just come by my office at any point to look at them. That's the only exam really that I hold on throughout the semester. And then the second thing is videos are graded as well. And so those are going to go up this weekend as well. So there's a lot of points coming up online. Just pay attention. Those, I'll give you guys the feedback on those on Monday, and those will be for you to keep, to treasure, or to like barf all over, whatever you want to do. And review session Wednesday 4 to 6. I just kind of, based on my schedule, that's about all that works. So I wanted to make sure that you guys are aware of that. And then next week on Monday, I will probably take a couple of minutes to review just again the objectives for this upcoming exam so that everybody's aware. Practice exams have gone up. They are the same ones as from the last unit. I just moved them into this new folder because I had done some switching the past 2 semesters of what goes on which of those, the second and third exam. Last comment. As we move into the last quarter of the semester, we're going to switch up groups one last time, but this one is going to be you choose you choose your own, a team of 4. And whoever you choose to be with is going to be who you will work with for the mini presentations that you'll have to put together. I'll explain those a little bit later on, but those are just 5-minute mini lectures that you're going to put up on VoiceThread, and we're going to watch them in class. Okay? So you don't have to stand here and talk, but you have to teach us about something we haven't talked about this semester. Okay? So start to think about who you want to work with for that one. If you don't have a home, let me know, and I'll kind of create like a free agent roster so that you can pick up people off the free agent roster too. Okay? So that's coming up. Anyway, all right. Let's get to talking about antibiotic resistance a tad bit more. Though I have to say, I was reading through some of your guys' comments this morning and really thought you guys put a lot of effort into it, so I was really impressed with that. I love watching TED Talks, only if they're interesting to me, but so I guess... but the big thing with this one is the focus around antibiotic resistance. And Maren McKenna just came out with a book within the past month or two focused on this topic more, but focused more on the, if I'm not mistaken, it's on antibiotic resistance development in agriculture. So it kind of takes a subset of what she talked about in this video and expands on it. What I wanted to do was to just go through a couple of the theories behind antibiotic resistance, and then we're going to break up into groups for a while and kind of revisit the video. We've covered this some, but I do want to kind of reiterate the point of how this occurs. So in cases where antibiotic resistance does develop, we have this is showing some persister cells that we haven't really talked about, but what I want to focus on are these orange-colored mutant-expressing, these mutants that have some sort of resistance factor. Now that may be a gene like a beta-lactamase. It may be a mutation in a gene that renders them resistant to a certain antibiotic. And remember, bacterial populations, they're heterogeneous. Even though we think of every single cell in a test tube being identical, there is some variation to those cells. And so because of those mutations that arise, we can find at low frequencies antibiotic resistance rising, the cells that are sensitive to the antibiotic dying off, and those that repopulate are the cells that are resistant. And what this ends up doing is, if you think about it, it really ends up shifting how much antibiotic it takes to kill a microorganism. Okay? Let's look at this one other way. So here is a population of bacterial cells. This is just a bell-shaped curve here showing you if you were to take each individual cell and determine what is the minimal inhibitory concentration of a drug for it, what you'd find is a distribution. Some cells within that population are much more sensitive. Many of them are resistant, or I'm sorry, many of them are intermediately sensitive, and then some we might consider to be resistant. And when we are doing minimal inhibitory concentration experiments, typically, we're treating with a dosage that kills or that inhibits the growth of this full population. So the MIC would be over in this concentration. That makes sense so far? Okay. What happens if we treat with a suboptimal concentration? So a concentration that's not enough to inhibit all. Ashley? Right. So who dies in this population? Or who is inhibited? Basically all of those that are sensitive or that are sensitive to that concentration of drug or less, right? So all of these cells would end up dying. Here are our survivors. And what we find is that when those cells regrow then, it shifts the population. And overall that population is more resistant than the original one. This is what we observe. Typically in a clinical setting is treatment with sub-inhibitory concentrations of antibiotics. And that can come in many different forms. What are some examples where we see this type of resistance arising? Or what kind of practices lead to this type of resistance, I suppose, is what I'm asking. Abby?
Just like if someone doesn't finish their course of antibiotics?
That's exactly one example. So if the individual doesn't take the antibiotic for the full time of prescription, what we can find are some of those remaining cells surviving, or some of the most hardy surviving, and then leading to a regrowth of that population. Absolutely. That's one example. What are other ones? Evan?
Like if you don't finish the antibiotics and you use it again another time for other things.
Yeah, absolutely. So using the antibiotic, and to go along with that, using it past its expiration date, for example. One of the things that we talked about are antibiotics are typically heat sensitive. Well, that also means that even at room temperature, over time, they're going to lose their activity. And so what you think, if you think you're taking 100 milligrams of a certain antibiotic, if it's been sitting in your, I don't know, kitchen cabinet is not where you would store them. Bathroom cabinets for 3 years or something like that. The effective dose or the amount that's actually there might be on the order of 80 milligrams instead of the 100 that you think you're taking. Okay? What else? Improper storage would go along with this as well. So like if you store the antibiotic in a hot car for a while, that's going to reduce its shelf life. Okay? And there are other ones as well that can contribute to this. All right, so this right here is, this came from the CDC, and the World Health Organization just came out with a similar list in the past month or two, and I haven't updated these slides to reflect that. But this is what the CDC considers to be the most pressing microorganisms that we need to be concerned about given antibiotic resistance. So if you look at the top there, what's the first one listed? C. diff, that's Monday's conversation, okay? We've also got carbapenem-resistant Enterobacteriaceae. Those are ones like E. coli, Klebsiella, Enterobacter that are resistant to carbapenem is a beta-lactam antibiotic. And then drug-resistant Neisseria gonorrhea, also a pressing issue as well, okay? Look at the serious, I think, where are we? So we've got some like those that have beta-lactamases, drug-resistant Campylobacter, which causes gastrointestinal disease, even fungal infections are being considered on these lists as well. We're finding fungus gaining resistance to not antibiotics but antifungals that we use against them. One that probably should surprise no one, MRSA's up on this list as well. And then its relative, the vancomycin-resistant Staph aureus bursa, is down here on the hazard level. Concerning. 3 stars instead of 5 stars. All right, so I'm going to stop there, okay? And what I want to do now is, given your guys' responses, what I want to do is just break into groups of, let's say, anywhere from 2 to 4. What I want you to do is pull up, if you can, your wiki. And I want each group to take one of those questions, and I want you to discuss those questions. Okay, so for example, if you're answering the first one on why are we no longer, or why does Marin McKenna argue that we are out of or ending this golden age of antibiotics, what I want you to do is take a look at all the answers from your group and the other groups as well. And I want you to come up with what you think might be the best response based on the collective responses of everybody that has contributed to that. Okay? So each group, if you're in a group of 4, you'll probably have anywhere from 8 to 12 responses to look at. I want you to read over those together, or talk them out, and then come up with kind of a summary response for why are we at the end of the golden age. Okay? Does that make sense, what I'm asking you guys to do? Now, I don't want everybody to do the first one. I'm hoping not everybody will do the second one. So I'm not going to tell you which one to do, but hopefully we'll get everybody to do at least one of those so that we can talk about it afterwards. Okay? I'm going to give you about, how much time do we need today? We'll go for 10 minutes. I'll see where we're at, and if we need more time, we'll go for an additional 5 afterwards. All right? Okay, feel free to spread out. I'll be walking around to talk too. So do you know what KPC is? KP is Klebsiella pneumoniae. The C stands, I think, for carbapenem. So it fits under that CRE that we just saw on that list. But yeah, resistant to all but 2, right? So I think the number she says is worldwide yearly 700,000 deaths per year. We see there's an increase in the amount of strains, clinical strains that are exhibiting what we'll just call MDR, or multi-drug resistance. Okay. What else? Derek? Yeah, so I'll just write resistance is fast. It looks like resistance is RAS, but that's supposed to be fast. Austin?
Like back in the day, like the beginning of the antibiotic age, they were very effective. That chemotherapy now are like bacteria where only like 1 or 2 types of antibiotics are effective in some cases. They're just completely resistant to all antibiotics.
Yeah, and I think that kind of fits with the multi-drug resistance as well. Absolutely. Absolutely. Emily. Yeah, so, and I don't know if that necessarily says we're out of the golden age, but that is definitely a reason why I think antibiotic resistance has developed. But but our speed. So our speed to produce is slower or less than the speed to evolve. I mean, one of my favorite quotes in that whole talk is, "Evolution always wins." What's that? Well, true. I'm not going to say evolution, it's evolution, but that's fine. Erica.
Resistance is fast. She showed that timeline that like we always gain resistance, but like when penicillin first came out, it took like 30 years, and then in the more recent years, we've been gaining resistance.
Yeah. So that speed of resistance that we observe, it has kind of accelerated as well, right? One thing I wanted to point out, because I've heard it a couple of times already, but I also saw it in what I was reading. What actually is gaining resistance? Yeah, it's the bacteria that specifically gain resistance. It's not us. Because remember, antibiotics are selectively toxic. They are designed to not affect us. So it's not us that's evolving, it's bacteria that's evolving. Do viruses evolve to antibiotics? No, because they don't the antibiotics aren't even designed to target viruses in the first place. Okay, they target things that are specific to bacteria. And I wanted to point that out because it doesn't irk me as much as it used to, but once upon a time I was very irked when people would say that we're gaining resistance, and that's not what's happening. So just wanted to point that out. In my old age, I've not become as curmudgeon-y about that. Other things, though. Children standing on my lawn is one of them. Other comments? Kevin.
When like she mentioned that the founder of penicillin, I forget his name.
Fleming.
Yeah, he like kind of predicted that
Yeah.
penicillin would be resistant in the future if like it was overused and stuff.
Exactly, and that's probably my second favorite quote in that one, is the one from Fleming, where he kind of notes that he predicts the misuse of antibiotics could lead to, in so many words, increased resistance or mutations that lead to resistance by microorganisms. And we've talked the mechanisms about which these resistance markers can spread, right? We've talked about they can be gained by mutation, or sometimes organisms just have these genes that inactivate antibiotics. For example, we think we're so cool. When we came up with methicillin as an antibiotic or when we identified it, and I don't remember exactly when it was probably the 80s, I'm going to guess. But when we identified it, that was kind of like a last resort drug at the time. We thought this is a game changer. This is going to be able to kill everything. We can find bacteria that are over 30,000 years old, frozen in permafrost, that actually have resistance markers to methicillin. Bacteria already knew, like it's as if they knew ahead of time we were going to try to do this. So I guess that oftentimes keeps me humble that no matter how good we think we are, they're always a step ahead. Okay? Those genes were already there. And so it's not as if these genes just become created. It's more of they're there, and now but through using these antibiotics, we're selecting for these what were very rare genes, and we've made them become a more frequent occurrence. In essence. Okay, let's move on to the next one. How have we accelerated antibiotic resistance? Derek.
Well, a big one is when we first introduced penicillin and other antibiotics, it was like over the counter too.
Yeah.
So they were easily accessible, which did not help the antibiotic resistance acceleration.
I think that's the accessible is a really good term, because I think that's broad enough that it defines multiple things that we'll talk about here. Absolutely. Austin and then Ashley.
Just like using antibiotics for like things your body could fight off on its own, and then it just leads to a weaker immune system.
And I'll clarify that one again too. It's not that it necessarily is weakening the immune system, because again, the the antibiotic isn't going to affect the immune system. It's more indirect, where overuse of those antibiotics may select for bacteria that again gain resistance to it, and now it's harder for the immune system to fight off that infection in some ways. And usually, one of the ways to think about this is antibiotics should be a supplement, right? And not like a daily supplement, but a supplement in the goal is to reduce the growth rate of bacteria enough so that it allows our immune system to kill the microorganism. And the idea behind some of those antimycobacterial antibiotics like ethambutol and isoniazid, they degrade or prevent the synthesis of the mycolic acid on mycobacteria. By blocking that synthesis, you increase the rate of phagocytosis so that the immune system destroys those mycobacteria. Ashley.
So like you're saying how if you don't go like your antibiotic, you can stop it early. Also she mentioned that it's in a lot of like agriculture.
Yeah. Yeah, so what was the benefit that has been seen with livestock? Growth, yeah. Somehow it promotes growth, and some have argued that growth promotion is because it's changed the bacteria that the livestock are exposed to. You could argue that it has beyond the negative effects of contributing to antibiotic resistance. And these are, when we're talking antibiotics in these, it's sub-inhibitory levels. It's not high concentrations. These are pretty low levels of antibiotics that are being used on farms. But what we find, farms are a high source of antibiotic resistance. And not only in bacteria, but we find lots of transducing phage that carry antibiotic resistance markers on farms as well. So we see a lot of horizontal gene transfer increasing the spread of antibiotic resistance. Emma you asked about organic. Like if you find food at the store that says it's organic, if it's certified organic, I'm almost certain, I'd have to double check on this, but if it's certified organic meat, that means there's no antibiotics being used. And a lot of companies are kind of promoting that now as well. I think a lot of people worry about that having an effect on, like some antibiotics having an effect on them. I worry more from the perspective of what's happening on the farm itself. And I say that because, for example, antibiotics are heat sensitive. I never eat ground beef raw or chicken raw, which is where we would find those antibiotics. The heat is going to inactivate those antibiotics. So the effect isn't to us, the consumer, but it's rather about the spread of antibiotic resistance on those farms where we see the bigger impact. Okay, so agriculture, we've got overuse in terms of prescriptions. And then I'm just going to erase this other one. Not full dose. What else? Any other factors? Anybody feel publicly shamed yet today? Nothing?
We also, like how hospitals and like healthcare providers give, like their patients medicine, and it might not even really affect the.
Yeah, and I think this one, is a big issue. And I think that this is one that I think all of these can be addressed. right? There are some that we can address. Take the antibiotics for the full course of the prescription. Get rid of the extra ones that you have. But don't dump them down the drain, because that will lead to antibiotics being in the water system. Agriculture, reduce the amount of antibiotics on farms, etc. That has been pushed, and the USDA is making a very large push on that right now. One of the areas where I think we can make some really big improvements is let's improve our diagnostic testing, right? So I don't know about you, but I've had times where like Jake has gone in or Reed has gone in for a rapid strep test. Those tests come back negative, but the doctor puts them on antibiotics anyways because it's going to take another 24 hours for the long-term strep test to come back. And sometimes they're positive and sometimes they're negative. I despise the rapid strep test. I think it's a piece of poop, to put it bluntly. I just don't think it works as well as they say it does, but I'll get off my soapbox for a minute there. But quicker diagnostic testing. Wouldn't it be lovely if from when you come in with an ear infection or when you come in with a cut that doesn't seem to heal, if within 15 minutes we could know what the source of that infection was or what actually was there? And then by improving that turnaround time, that would allow us to better select a narrow spectrum antibiotic, for example, rather than a broad spectrum that might allow us to specifically target the organism that's causing the disease. We don't really have those diagnostic tests in place right now. Most tests are 24 to 48 hour tests. So let's work on that. I think that's one area where research can go, at least, to really improve some of the clinical practices for antibiotic usage. Yeah. Any others? There are some that argue also that some of these infections, and this kind of goes with the overusage part, where some infections should be able to just clear themselves naturally. Your infections stink, yes, absolutely, but there are the number of doctors now that are not prescribing antibiotics for an ear infection or for a sinus infection, that number is increasing. Because of the fact that those are types of infections our immune system should be able to take care of naturally. I want to also point out here real quick, there's a lot of overlap between antibiotics and vaccination. There's some similar conversation pieces. We'll come back to the vaccination talk later on, but the use of antibiotics is not only for a benefit to ourselves, but who else is it a benefit to? Yeah, other people, immunocompromised individuals. And the same is true for vaccination as well. And so there's some similarity there in thinking about this more broadly beyond the me-centric version. Okay. Couple of quick couple of quick ideas. How can we encourage companies or researchers to identify new antibiotics? Kaylin. Yeah, so more discovery grants, make the patenting easier, prizes for discovery of these in the first place. Other ideas? I think these are kind of the major ones she hit on, and they were all kind of financially based, because what we find right now, big issue is pharmaceutical companies don't go into the business of making antibiotics. Oh boy, here we go. All right. If you were running a business, a public business, what is your primary objective as a business owner? Money. Make money, okay? The almighty Aller. And if you think about drugs, medications for a couple of minutes, what are the most profitable medications? Why?
Because they're effective and people don't like being in pain.
Okay, painkillers. I'll put that one down. What else? What are profitable drugs?
Over the counter,
Like what kinds?
like ibuprofen.
Okay. Others? I'll give you the one that I think might be the most profitable, or close to the most profitable. Why? If they don't take it, they die. If you are diabetic, you have to take insulin every day of your life. If you are HIV positive, you need to take those drugs every single day of your life for the remainder of your life. In other words, the drugs that are most profitable are ones where you've got a repeat customer. You've got somebody coming back again and again and again. And that's where the money goes, is to put money into development of heart medication, Viagra. Those are what make money, okay? With an antibiotic, you don't necessarily have a repeat customer. You've got somebody who's taken the antibiotic for maybe, depending on the illness, depending on how bad it is, somebody who's taken it for a week, and then that's it. Vaccinations, same argument, why we don't see as many going onto the market. You've got somebody who gets a preventable vaccine that is meant to be preventable. For some of these, they're so effective that we think you only need 1 or 2 shots for your lifetime, and that's it. Others, we think you might need boosters, but still, it's kind of a drop in the bucket compared to some of these long-term medications. Okay, so some, myself included, would argue that companies aren't putting the energy into this because it requires a lot of work, there's a lot of hoops to jump through, and it doesn't pay off in the end. From about time of discovery to getting on the market for a lot of the drugs that we talk about, it's about 10 to 20 years. Because you have to first prove that, or show proof of principle, it works on non-living, or I shouldn't say non-living, in cell culture. And then you have to go to animal models. And then you have to go through 3 rounds of trials with human participants. And those 3 rounds of trials, the first is just to determine what's the toxicity. The second is kind of a small-term study to determine is it effective. And the third is a large-scale study. And those all cost a lot of money to run. Okay? Because oftentimes with those, you're giving out the drugs for free as well. And for every 100 drugs that are proposed to be used in the beginning of this whole thing, maybe 1, 2 will make it out. So companies have to put in a lot of money up front in order for there to be a payout with drugs. And that's just how it works right now. Because of that, some would argue that this is what's leading to a lack of antibiotics going onto the market. And if you look at who's making the biggest push right now for finding new and novel antibiotics, it's people at research institutions and research universities. It's not pharmaceutical companies. And so awarding more grants or awarding prizes for these would maybe encourage some companies, but definitely would be supportive of the people who are kind of first trying to identify these antibiotics. The downside of this, and this is not a knock on Trump, but a knock on how government has funded research over the past 20 years, if anything, given the cost of inflation, the amount of money that's being awarded has gone down rather than gone up. And so we're actually losing grant money rather than gaining grant money to support this kind of work. Okay. Last one. How can we stop the spread?
I feel like this one was just kind of a lot of times the reverse of question 2.
Yeah. So don't prescribe willy-nilly. Make sure we know what the infection is before we prescribe. Take the full dosage. Reduce the amount on farms. What are other things that we could do, just daily practice, that might stop the spread of antibiotic resistance buggers? Kaylin?
Wash your
Wash your hands. Exactly. Good hygiene practices. If you're going from, and we'll talk about C. diff a bit more on Monday, but if you think about what's going on in the hospital settings in terms of C. diff, it's an infection that spreads very easily. So if you think of best practices in the hospital setting, those are the types of things that we need to encourage not only in the hospital setting, but broadly in order to reduce at least the spread of antibiotic resistance for some microorganisms. Okay? All right. Any questions on this? Or any thoughts that anybody has? Okay. Let me just move to one more thing real quick then. All right, let's finish up today with this question at the end here. This is not necessarily a challenging question, but I think does a really good job of just kind of reiterating the points that we've talked about. Okay, and this is, and for many of you, this is what you will see on a daily occurrence, whether it be in your profession, whether it be at home, whether it be family members, etc. So it says a patient with streptococcal sore throat takes penicillin for 2 days of a prescribed 10-day regimen. He feels better. He then saves the remaining penicillin for some time. After 3 more days, he suffers a relapse of the sore throat. Discuss the probable cause of the relapse, and let's take it one step further. After discussing the probable cause, what would you, if let's say that this is a patient of yours, what would you tell them that they have done incorrectly? Okay? How do you publicly shame them? Okay? Take a minute to think about it, and then we'll discuss it.